Excuse me, ladies and gentlemen, we now have our presenters in conference. Participation in this presentation is by express written invitation of the AHA only. Unauthorized participants and or any party that aids and abets such unauthorized participants may be subject to criminal and civil penalties under both state and federal law. Please disconnect from the call or log off the webinar if the AHA did not expressly invite your participation. Please note you may submit your questions electronically at any time using the chat pod located to the right-hand side of your webinar platform. It is now my pleasure to turn the conference over to Sun Cow. Please go ahead.
Thank you, Stephanie. Happy Engineering Week, everybody. Thank you for joining the Ask ASHE webinar for quarter 4. Before we start, we should have a few housekeeping items. This session is being recorded and will be available on the members' ASHE On-Demand Learning page. Future Just Ask ASHE webinars will be for quarter 1 will be January 27th at 12 p.m. noon Central Time. Quarter 2 will be April 20th, 12 o'clock noon Central Time. Q3 will be at the ASHE Annual Conference from August 2nd through 5th in Chicago, Illinois. And Q4 will be on October 26th, 12 p.m. Noon Central Time, and that will be next year National Healthcare Facility and Engineering Week. A little disclaimer before we start. The responses and interpretation are an explanation of a specific provision of a code, standard, or guideline. While every effort has been made to ensure its accuracy or reliability, it is advisory and provided for information purposes only. For formal interpretations, please submit your question to the code/standard development organization for an official interpretation. Jonathan, would you like to start?
Thanks, Don. Appreciate that. Today we have our subject matter experts come from the NFPA, from the Joint Commission, and from a couple folks representing the International Code Council. I'd like to introduce our subject matter experts. Our first subject matter expert is Mr. Richard Veland. Richard is currently a principal engineer for the NFPA. Richard is responsible for NFPA 99, Healthcare Facilities Code, telecommunications, electronic computer systems, aviation, and other related standards. Richard holds a master's degree in fire protection engineering and a bachelor's degree in electrical engineering, both from Worcester Polytech Institute. Prior to joining NFPA, Richard worked for the National Fire Protection Research Foundation, for several fire protection consulting firms, and he worked in the electronics industry. He has published many articles on a variety of fire protection, healthcare, and security subjects, and Richard has worked for the NFPA for over 30 years. Welcome, Richard.
Thank you.
From the Joint Commission, we have Mr. Herman McKenzie. Herman is currently the director in the Standards Interpretation Group of the Joint Commission. In this role, he manages all activities associated with the daily operations of the engineering department, provides standards interpretation and education to the Joint Commission's surveyors. Herman comes to the Joint Commission with over 30 years of healthcare experience, having held managerial and director-level roles in clinical engineering, plant operations, and facility services throughout the Chicago area. Herman holds a bachelor's degree from Southern Illinois University and an MBA from Governor State University. Herman is a certified healthcare safety professional, a member of ASHE, and the Healthcare Engineers Society of Northern Illinois, HESNE, where he served as president from 2013 through 2014. Welcome, Herman.
Well, good morning.
We also have Mr. John Williams, who's the manager at Construction Review Services for the Washington State Department of Health. John has over 25 years of experience with healthcare design and regulation. He's the executive director for the Washington State Department of Health Construction Review Program, which reviews the licensed healthcare facilities for state licensing, federal certification, and building code requirements. John also serves as the chair of the International Code Council's Committee on Healthcare. He also serves on the FGI Guidelines Steering Committee and technical committees for NFPA, and the Washington State Building Code Council. Welcome, John.
Thanks for inviting me, Jonathan.
And our last subject matter expert is Mr. Jeffrey O'Neill. Jeff is the Senior Director of Facilities at Penn Medicine's Pennsylvania Hospital, the nation's first hospital. Previously, Jeff served as a Senior Project Manager for Penn Medicine's Real Estate, Design, and Construction Department. Professionally, Jeff received his Bachelor's of Architecture degree from the Catholic University of America and is a registered architect in the Commonwealth of Pennsylvania. He holds a healthcare planning certification from the American College of Healthcare Architects and is a certified healthcare facility manager. Jeff is a member of professional societies in the field of healthcare architecture and is the vice chair of the ICC Committee on Healthcare and has served as the vice chair of the International Code Council International Existing Building Code Committee for the 2021 cycle. Welcome, Jeff.
Good to be here, Jonathan. Thank you.
All right. With that, we're going to jump into our questions. Our first question today has to do with fire stopping. The question was submitted and asked specifically, do you see consensus forthcoming as fire as independent inspections for fire stopping in healthcare buildings? John, you want to handle this one for us?
Sure, Jonathan. Well, I think there's a lot of broad consensus out there that there are challenges with our existing systems and existing buildings. Certainly, when I go on inspection, this is one of the most common citations that I notice out there in the field. At ICC, we've heard a lot over the last couple of years where there's been proposals to increase the qualifications of installers and increase the oversight during the construction process. And while those could address some of the issues that we see during one phase of the building's life, I think we've got to acknowledge that a large part of the problem exists after the project is complete during ongoing building operations. Right now, the third-party verification that exists is our local building inspectors, our state fire officials, our federal certification and accreditation organizations. I think we are still in a space right now where owners and operators have an opportunity to solve this issue on their own before one's mandated. But that window is going to close at some point because we've heard about this problem for a long time. So I think that, like I said, there's a window. But we've already heard some rustlings about mandating those requirements, and those would not only be construction requirements, but maybe some ongoing facility requirements.
And this is Jeff. To add to what John is saying, particularly the part about when the project finishes, this largely becomes a quality control issue for your maintenance department. In healthcare, we're always upgrading, particularly on things like technology and systems where you have a lot of wire being run above the ceilings. That's your main culprit. The contractors that are moving above the ceiling through the barriers, if you don't have a robust quality control features in place, such as above ceiling permits, active punch list management when you're finishing a project from the facility, those are all good examples of quality control approaches to help fire stopping for that day when you are being inspected either by the state or Joint Commission or CMS to be ready for when they randomly look at a barrier. The best way to inspect these is to do those random checks. You have to make sure that you're paying attention to the barrier in its total composition.
And just another point there, Jeff, very important stuff that you provided there, you and John both. But when we did our focus on compliance review, where we did a root cause analysis, we also found a big issue with conduit, new conduit being added to building. And we know a lot of times that happens to be facility staff. So making sure that your facility staff are very familiar with the above ceiling permit process and are following that, as well as any contractors, is very important also. Any other insights on this question? All right, moving on to our next question, door inspection. Does the Joint Commission require NFPA 72115 inspections of door openings to be applied for door inspections since the healthcare occupancy doesn't reference this code section? Herman, can you handle this one for us?
Sure. So the short answer is yes. Actually, so if you look at our EP, that's 235 EP25. Actually, there's a numeral missing. EP25. We do reference this in the notes for more guidance on inspecting doors. So that's in the notes. We do reference that section of NFPA. So it's October of 2019. So we're almost 2 years into this EP now. And I can tell you, it appears that most folks who are doing the door inspections are pretty compliant. So that's the good news. So, the issues that we're finding is, when you conduct your door inspections and that you do find deficiencies, it's important, I must note, it's important that you follow up to correct these deficiencies with the doors. But I would say overall, most organizations are pretty compliant with this.
Thanks, Herman. Any other input from anyone else? All right, let's move on to our next question then. We received a question in regards to smoke detector sensitivity testing. What is the required frequency for smoke detector sensitivity testing? Rich, you want to handle this one?
Sure. Yep. In NFPA 72, we talk about some sensitivity testing, not to be confused with functional testing, which is just can smoke get into the smoke detector. So sensitivity testing is actually looking to see if the smoke detectors are still within the listed sensitivity range, or I think it's 4% obscuration per foot. And we do that by check. Well, and I'll tell you some methodologies on how we do that. But basically, we check for the sensitivity with 1 year of installation. So after a year, we want to make sure that the smoke detectors are still functioning properly, that they're still within the sensitivity range. Then we start switching a little bit. We figure that if they're in spec that first year, we kind of relax a little bit and we allow them to go every alternate year. So every other year then they go through and do another sensitivity test. Then we kind of give them a break again. So if we have 2 successful sensitivity tests and everything is still within spec, we kind of say let's relax a little bit and we'll extend that out to about 5 years then. So it gets a little bit easier with once we start proving success and the detectors are still within their sensitivity marking or sensitivity range. So and then what is sensitivity testing and how do we do that? What are the recommended methods or ways that NFPA 72 requires it? And one of them is a calibrated test method. So there's, in the old days, I remember there used to be an instrument that put an aerosol into the detector at a known obscuration rate so that they can test the detectors that way. Don't know if that equipment is still around or not. That was kind of a long time ago. But now manufacturers also have calibrated test instruments and pieces of equipment that they can go and test their smoke detectors with their own equipment that's been calibrated for sensitivity. Some of the control panels are equipped to look at the sensitivity of the detectors from the control panel. So the systems have gotten smarter over the years, and they can go out and pull the detectors and determine what sensitivity rating they have on those now. Also, if the control panel is a smart panel and it can actually tell you when the detector is out of sensitivity, then that's another way of doing it. So it's constantly monitoring the sensitivity and will notify you when it's outside of it. And then the last method is if there's an approved method by the authority having jurisdiction. So that kind of covers the stuff that's not in the standard, and if something new comes up and it's approved by the AHJ, then they're allowed to use other methods that's approved by the AHJ. And I think that pretty much covers the sensitivity testing from an NFPA 72 standpoint.
Excellent job, Rich. I would just add one thing. Be aware this is something you need to make sure if you're contracting out these services that this is in your contract. Because if it's not specifically in your contract, it's probably not going to be done by your contractor. So making sure that you list the sensitivity testing in your contract is very important. Any other comments or input? Our next question is in regards to the generator remote stop. Why can the remote stop not be mounted on a generator enclosure for an exterior generator? Does anyone have an official documentation from CMS and Joint Commission regarding this or requiring this? Herman, you want to address this one?
Sure. So, NFPA 110.210, which is the edition that 101, the 2012 publication references, is not prescriptive about this. I know I've been approached by, customers that said, later versions provides a little more guidance, and I don't disagree with that. However, 110 is not prescriptive, and we have so. By the way, to address the issue about do we have official documentation from CMS? Time to time, there's interagency communication between CMS and Joint Commission. But that is for our internal purposes only. I can tell you for almost 3 years now, we have been enforcing the do not install on the housing rule. And the purpose of that is if there is an external generator and something had an event, we want to make sure that the person who is turning off the generator is at a safe distance, and that we wouldn't have an unfortunate or a created hazard or that person become injured. So it's all about safety. Most of our customers have, by this time, they are compliant, and even if there's an issue of a modification, I have not seen where it's caused that much of a hardship. But yes, we are all still supporting that the remote stop cannot be on the housing of an exterior generator.
Thanks, Herman. Any other insights on this?
Jonathan, this is Jeff. From a facility perspective, I would just like to reinforce what Herman was saying about the safety issue. Everything we're doing with things like arc flash and making these panels safe has to do with keeping that safe distance away. So when we're talking about a remote stop on an exterior generator, again, you really do want to be as far away from any incident going on when you're around those type of electrical loads, because you never know what's going to literally jump out at you from getting too close to a piece of equipment like that.
Also, this is John. I appreciate the comments, and I would one of the things that we look at when we look at these locations is it tamper resistant? Is it located in a way so that just anybody driving up wouldn't reach up and be able to operate that remote stop? Because it is an important component of facility operation, of course.
Good points, folks. Yeah, we are not prescriptive on, it has to be X amount of feet away or mounted at a certain height. But yes, good points. Make sure that the public cannot tamper with it. So if you have to mount it on a bollard or something, and then create another safety something to prevent the public from accessing it, that would be the expectation. But great points to bring up, folks.
All right, thanks everyone. Moving on to our next question. This is in regards to cylinder and container storage. Are the cylinder and container storage requirements intended to pertain to all cylinders or just full ones? Rich, you want to handle that one?
Yep, sure. Yeah, in the 2012 edition, in Chapter 11, we talk about cylinder and container storage requirements. Cylinder is compressed gases, container are the liquid gases, and those are in containers as opposed to cylinders. And what we have in there are the 3 levels of storage. So we talk about storage over 3,000 cubic feet of gas, and then the middle level is under 3,000 but more than 300 cubic feet of gases. And then the third level, the lowest level, is if you're under 300 cubic feet of gases. And questions used to come in saying, are we talking about full or empty cylinders? And it doesn't quite say that, or it doesn't differentiate it in Chapter 11 of the 2012 edition. So that question came up enough where that in the 2018 edition, the committee decided to clarify that and say that it is only for full cylinders. So full cylinders have to meet those requirements that are found in Chapter 11, and you still have to segregate out the full cylinders from the empty cylinders because you don't want to get any confusion and have a mix-up and somebody grabs an empty cylinder. So those still have to be separated, but the requirements for the storage and how to separate the storage and what the requirements are for ventilation and clearances to combustibles and stuff like that is all for full cylinders found in Chapter 11 of the 2012 edition of NFPA 99.
Thanks, Rich. Anyone else have any insights on this? Okay, let's move on to our next question. That's in regards to corridor definition. We have a member that would like an official definition of what constitutes a corridor. Jeff, you want to take this one?
Sure. Everybody likes a nice, simple definition, I guess. So happy to answer this one. In the IBC, and therefore, since in the IBC, it applies to all the ICC family of codes, a corridor is pretty simply defined as an enclosed exit access component that defines and provides a path of egress travel. That sounds nice and simple, but when you go to the relevant chapters in the Life Safety Code and the IBC and even the Fire Code, those components that define and provide that path are a great multitude of things of what they can and can't be. There's also, like, for example, when you're marking your exit with the exit signs, the illuminated exit signs, you're, depending on if you're in a fully sprinklered facility or not, you're making the walls rated if you're not sprinklered or resistive to the passage of smoke if you are sprinklered. The same goes for the ceiling. And there's debate around what the ceiling needs to be components are for resisting the passage of smoke. But also when you're talking about a corridor, you're talking really about moving the occupants of a building safely to an exit. So there's other sections that take you and define which of those spaces need to be connected to a corridor and therefore get you safely to an exit. The IBC Chapter 407, which is the healthcare specific chapter of the IBC, requires that every habitable room in an I2 occupancy, and that's both nursing homes and hospitals, have that exit access corridor that leads you directly to that exit. So so it's really, if you're thinking about it very, very simply and from an elementary sort of perspective, that you want to move occupants of the building safely to an exit while keeping them as safe as possible. And that's what the corridor concept is set up to do.
Yeah, and Jeff, I would add, I agree with everything you said. The international codes are a little odd in that they define this, and usually it's considered bad form to put requirements in definitions because definitions are really intended to tell you what a word or phrase means, not, you know, set charging language for something. So you pointed out one here that to me is one of the few places where the building code is going to tell you that you have to have a corridor. and that's the healthcare specific around habitable rooms having a door that leads to an exit access corridor. And NFPA is pretty consistent with that concept about suites or direct access to a corridor. The exception to this would be creating a suite where that long, skinny room, that enclosed exit access component, actually becomes an intervening room. So in that example of what happens inside of a suite, we've got something that fits the definition, but there's some other section of the code that gives you another way of labeling or defining it. So ultimately, I think these are theoretical kinds of decisions that need to be really clearly documented in your design and then in your statement of conditions as well. And there's some other criteria in Chapter 10 of the IBC that is going to let you know when these corridors need to be rated. So there are certain thresholds that you're going to cross over, and the building code's going to say, well, based on occupancy, you get a 1-hour corridor. But I see lots of people enforce this definition, using this looks like a duck, walks like a duck, quacks like a duck, then it is a duck kind of logic.
That's a good point, John, about bringing up the impact of a suite. That's something often when you're in the field, either on an inspection or in a plan review. If you think of a suite as basically a large room that's protected the same way as a room would be, including the components that touch the corridor, those intervening spaces become a point of debate. How far do you go to protect them the same way? So having that clarity of what's a suite, and then from the suite through the corridor to the exit is something that you really have to be mindful of in terms of scoping out the construction.
Yeah, because if you're standing in it, how would you know? Unless you look at your statement of conditions. Yeah.
So we did just receive a question in the chat box. Is there a requirement of width of corridor within a suite?
Well, this is John again. I think there are a couple of different things to look at. If you go to the FGI, Facility Guidelines Institute Guidelines for Design and Construction of Hospitals or Outpatient Facilities, there are going to be certain cases in there where they define a width, but it's based on the operational needs of that space, not necessarily egress, but more the operational. How much room does it take to get a bed or a gurney back and forth? In the building code, I would say that once we're in a suite, we can start talking about aisleways and things like that have set widths defined. But again, it's kind of based on use. And I think the FGI language is based on use as well. And it goes back to some of those familiar concepts that we're talking about, like bed or gurney movement. If that occurs within a suite, sometimes it's based on particular use, whether it's a space between a PACU and an operating room where you can pretty well predict that there's going to be some sort of bed or gurney traffic.
Great. Thanks for jumping on that one. Any other comments or insights? All right. Our next question is about weekly ATS inspections. What is expected of the weekly ATS inspection? Rich, you have this one?
Yep, I do. This is actually kind of a vague question, or you won't find answers that are really specific in NFPA 99 or NFPA 110. And eventually I'm going to be getting us into 110, but I'm going to start by how I get the 110 from NFPA 99. So in NFPA 99, in Chapter 6, and specifically in Section 6.4.4, it's administration. And under administration, we talk about doing some inspection and testing. And if you want a specific section, It's 6.4.4.1.1.4 subpart A, and that's the inspection and testing test criteria. And basically what they're saying is that the generator set has to be tested 12 times a year, no less than 20 days, no more than 40 days, and they say in accordance with NFPA 110 Chapter 8. So nothing specifically so far is talking about automatic transfer switches. But then we go to 110 Chapter 8, and Section 8.4 of NFPA 110 is in its operational inspection and testing. And what they say is the emergency power supply system and its pertinent components, and that's where the ATS is going to be pulled in, is in the part that's pertinent components. It says shall be inspected weekly and exercised under load at least monthly. And when we say inspected weekly, it's like what does inspected weekly mean? And that's just more of a visual thing. You know, if you think about your car, when you have your maintenance log for your car, and it says every, we'll say 15,000 miles to inspect the brakes or check the tension on the serpentine belt or alternator or something like that, where it's just an inspection, you're more or less just visually looking at it to see if there's anything wrong that's obvious. You know, so with an ATS, it might be, you know, do you see any corrosion? Do you see any signs of overheating over there? Is there any damage? Is it clean? Is it dirty? Is it accessible? Is there something in the way now that makes it inaccessible so you can't get to the automatic transfer switch? So you're just visually going in, taking a look at it, looking at it, and saying, how does this look? Does it look fine? Does it look like I have an issue? Do I need to investigate a little bit further? So that's what they're trying to do with the inspection test, and that's a weekly thing. And one thing they do talk about in NFPA 110 in the annex is they want to stress that they're not running the generator on a weekly basis. It's on a monthly basis. And one of the things they talk about is that it actually could be detrimental to the generator if you're running it too often, for instance, weekly, and if it doesn't get up to temperature, you might get what they call a wet stacking effect, where it doesn't get up to temperature and you get unburned fuel in the stack, and you have what they call wet stacking. So some of these things can happen if you're testing it too often. So the visual inspection is weekly, and the monthly testing for the generator under load is on a monthly test, or monthly schedule, I should say.
Great, thanks, Rich. Any other insights or comments on this one? All right, moving on to our next question, which is in regards to fire watches. Related to NFPA 101 and 25, when fire watch is required, is there a requirement for how we conduct fire watch? For example, one person rounding on all affected areas versus having a person continuously present in each affected area. Herman, you want to talk to this one?
Sure. So I could say unless the code, in many cases, unless the code has prescriptive guidelines, the Joint Commission recognizes that, as many organizations are out there, there's probably that many ways of skinning a cat, so to speak. So we do not prescribe how you should conduct your fire watch. That's totally up to you. However, let me make a couple recommendations. Should always have the key stakeholders, right? Anyone that's involved in why you're having the fire watch because of the area, under construction, etc. They should be involved. They should know what's going on. Also, you have to make sure that your operational practices will dictate, how this is conducted. How do you have your shifts for your maintenance? How you have your shifts for your security staff? Those things will play a part in how you craft your fire watches. So if you look, NFPA 101 Life Safety Code in the annex, they do have a note about how making a suggestion about your fire watch. and it said that it should involve action beyond the normal staffing. So the assumption is that your normal, staff has tasks and duties that they're already doing. So they should go beyond the normal staffing, and probably most important that I'd like to make sure is that the individuals assigned, they know about fire prevention, all right? And then secondly, or probably in addition to this, maybe 1 and 1A, they know about occupant and fire department notification. So it's not just, well, you assign a staff member from security or your maintenance staff to come in and work an extra shift to do a fire watch. They must know, number one, what they're looking for, and I don't mean to sound oversimplistic about that. And then also, you should have develop a process if they do see something that how they're going to notify the occupants of the space or the building, and then also how they're going to notify the fire department. So those are things that should be pretty well covered in your process for a fire watch. So I started off by saying the Joint Commission does not prescribe how you are going to conduct your fire watch. However, if on part of a survey process and we see that you have a policy or a process outlined and you are not following what you said you would do in case for a fire watch, that is subject to we would make a note of that as an observation. So make sure that you have some good processes in place, and then most importantly, make sure that you're following the process that you've outlined.
Thanks, Herman. Any other comments or insights on this one?
I would just like to add the part about the training. Even when you're dealing with either a physical plant department or your security group, that fire training is something that you really want to make sure that the person assigned at this fire watch is capable of doing. It's something you almost take it for granted, but if you're bringing on a new employee or somebody that way, if you're making that assignment, I really recommend that part of that assignment become that training, either a module working directly with a safety officer to go through exactly what they're doing, and that communication piece. Many people use security because a security console will have that direct line to the fire department. So keeping that as simple and straightforward as possible is also key, because the whole point is if you see something, you want to catch it very quickly.
All right. Any others? Okay, we'll move on to our next question. This one's in regards to dead-end corridors. When does a dead-end corridor become a dead-end corridor? John, you want to tackle this one?
Sure. So I think this is one where we have to look at our terms a little bit. And the question is about corridors, and there's this word dead end. Again, we just saw the definition of corridor, which is a corridor is an enclosed egress component that defines a path to exit. But when I look at the codes that I use, whether they be NFPA or ICC codes, they don't really define what dead end means. So I've heard it described a lot of different ways, and the best way that I can understand it, and I would offer to everyone on the call, is to tell a story. So just pretend, first of all, that you're inside of a corridor, and again, using that definition we just talked about. Also imagine that this corridor has got branches or offshoots that are going to lead you in different directions. So there's going to be a place where you have a choice of two ways to go. If you go down one of these branches, and it allows you to continue in that same atmosphere until you hit an obstruction like a wall or a door or a large piece of equipment, when you hit that obstruction, if you've got to retrace your steps back to that main corridor to get to an exit, then that branch is a dead end. So to me, the fact that branch of that corridor is a dead end starts as soon as you have to turn off of that main corridor and you're going in a direction that doesn't lead you to an exit. So when you're in a spot where you have to retrace your steps, that's a dead end. And that could be 2 feet down that corridor. But again, or to look at what the code actually says, the code allows dead-end corridors. It just places a limitation on how long they can be. And that limitation is based on occupancy. I think right now it's 30 feet in hospitals, 50 feet in outpatient facilities. But it also depends on whether it's an existing condition or not. Some of our existing buildings have existing dead ends that were approved at the time of construction. And I think there's language in our code that says if that existing approved condition is technically infeasible to correct, then it's allowed to be maintained in place.
And John, to flip it around a little bit, if you're in a space that's at the end of where this corridor is serving you, if you picture a T-type corridor and you're at the bottom of the T, and the stair towers are at the top horizontal part of the T on either end, that part when you're coming out of the space that you're in into that little portion of the T where you only have that one direction to go, that's your dead-end corridor. So when you get to that point where you now have 2 choices to make a left or make a right, that's really the best way to sort of envision when that dead-end corridor stops being a dead-end corridor. So just trying to flip it around a little bit, that if you're in an incident where you need to walk away from your space and get to the exit, keep that sort of T-mind in. And when you have that choice of 2, that's when the dead-end corridor does not, dead-end corridor stops.
Right. And that concept of choice of 2 different directions to go, there's another term that exists in many of the life safety and fire safety kind of codes called common path of travel. And those are similar. Common path of travel applies outside of a corridor even. So, we've mentioned the scenario where you've got a long, skinny room inside of a suite. It's not defined as a corridor, but you can get in a situation there where you would apply the common path of travel calculations, which is more of a travel distance kind of assessment, and come up with a similar type of situation.
Great. We do have an additional question on here. If a dead-end corridor is locked, but rather released during a fire alarm, is this still a dead-end corridor? So I'm going to throw an assumption in there for you, Danny. I'm assuming you have a door that is normally locked at the end of this corridor that releases once the fire alarm goes off. John, you want to address that?
Sure. I think we have to be careful with our locking arrangements because we presume that the fire alarm is always going to be going off in a evacuation scenario, and I don't think this is always the case. I think about in my region, you've got seismic events, you've got active shooter events. There are all sorts of reasons why a door that may drop on fire alarm, you may find yourself in a scenario where the fire alarm's not going off and you're still in a spot where you've got to navigate that corridor, maybe in an extreme disaster without much light. So I think I've heard it interpreted different ways, but I think that lock is commonly going to get you a citation.
Now, I'm just going to jump on this one also. There are some situations where we have these type of locks that are delayed egress locks, and those wouldn't get you that type of citation, and they're more for a security issue, such as your pediatrics ward or something of that nature, where you've got that back door secured so that nobody can escape with the child or some of that nature, but it's a delayed egress, and it's something I can push on, and within 15 seconds it's going to release, and then I can continue on. That would not be considered a dead-end corridor.
Right. Because in that case, the code is very specifically defining the delay, that delay in seconds that is acceptable.
Any other comments or insights on this? All right, we're going to move ahead to our next question, which is on medical gas tubing. Rich, you want to handle this one?
Sure. Yep. When it comes to the medical gas tubing, historically and for a long, long time, it's for positive pressure gases, it's always been a hard-drawn seamless copper, and it has to meet the requirements of ASTM B819. So for the 2012 edition, that's pretty much what's allowed for positive pressure tubing. And I mentioned corrugated metal tubing because it's something that is now new, and it's in the 2018 edition. And you might run into that in situations where you might have renovations or even new construction if you're still following the 2012 edition. So now you got this new method of having a medical gas piping or tubing, and you want to know whether it's allowed or not allowed. So I just want to talk about that just a little bit. So in the 2018 edition, they do have what they call a listed corrugated metal tubing, or CMT. It has to meet an ASTM standard B103, B103M. So it's very specific as far as the type of material and how it has to be constructed and built. This material, actually, the technology was really first came out when it for natural gas appliances, and they were connecting some of the appliances and furnaces, tankless hot water heaters, and so forth with corrugated stainless steel tubing. So it's very specific for that industry, and the industry came to the Pipe Gas Committee with NFPA, and they made their pitch and talked about how it should be allowed and why it should be allowed, and the committee discussed concerns, and they went back and forth, and eventually it was accepted by the committee for the 2018. So just be aware that it's out there, and it's probably going to be, you're going to see it and run into it more and more as you go into the future, but not allowed by the 2012, but it is allowed by the 2018. And I just wanted to kind of point that out for you.
Thanks, Rich. Any other comments or insights on this? Okay, our next question, it has to do with medical gas testing in the ambulatory surgery center. Most of the information we have found speaks to the regular testing and inspection of the med gas systems in acute settings, but what about ASCs and ambulatory clinics and digestive health centers? Testing of the master panel and manifolds are established, but what about the outlets themselves and frequency? Jeff, you want to handle this one for us?
Sure. So this is really, I guess, the two-part question here. And quite simply, in the ASC setting, we're still following NFPA 99 for all that testing criteria. When you think about it, that makes sense. It's all the same systems, hooks up to the patient in the same way. The only difference is that you're not spending overnight in the facility or an extended stay that way, but the procedural type areas really need to follow NFPA 99 that way. So you're following that for an ASC or endoscopy centers and in any business occupancy, as well as the acute care setting. In terms of the outlets themselves, the 2012 version of NFPA 99 does allow for a risk-based approach. The only time it really is talking about testing the outlets themselves is when you're working on the system or breaching the system, and everything from that point where you're making a modification or a cut into a pipe, everything from there downstream, you're really going to be testing to make sure that there's no sort of metal fragments in there and that the the outlets are clean. So every time we do work, we come in and get the system recertified. This is either in a major construction project or right down to sort of a maintenance level. If you're doing some level of modification or repair to the system, you're certifying those outlets that are downstream of the work to make sure that they're safe and be put back into service. So I'd be very interested to hear what the rest of the panel has to say about this as well. But it really does speak to sort of a risk-based approach on if you're going to be continually testing at the outlets as well.
Yeah, this is Rich Beelen. You're right, and 99 is kind of general, and like you said, risk-based approach. They talk about the periodic testing for the non-flammable medical vacuum shall be, or it should be periodic testing, and it shall be implemented. But they don't tell you what the periodic testing is and how often that is. And I think it really varies by your facility and what you have going on there. And as you were saying, if you're starting to breach the system, then you're definitely going to have to do some additional testing, just as if it's a brand new system with the installer testing and the verification test. So you look at particulates in the system, make sure there's no hydrocarbons in the system, and there's other tests that the installers and the verifiers do to make sure it's a nice, clean system once you breach it. But prior to that, I mean, your facility, when it comes to periodic testing, might be we need to do it every year. Another facility might be we need to do it every 3 years. Another one might be every 5 years. So they purposely, I think, left it kind of open-ended for your specific facility and just talked about a periodic testing. That period is determined by you.
So this is John. Rich taught me this, so I totally agree with Rich and Jeff on this. There is a requirement for an annual review of bulk systems. I mean, that's not getting down to the level of outlets, but if you are attached to a bulk system, I think that might be one hard and fast type of rule. The other thing that there was a potential is NFPA 99 is often adopted by other codes and standards, frequently the plumbing codes. So I went back both to the Uniform Plumbing Code and the International Plumbing Code to see if they've modified any of the testing requirements, and I didn't see any. So I think all of that defaults back to NFPA 99.
Yeah, and specifically the section that talks about that is in 5.1.14.4, and there's a bunch of stuff in there, but that specific section is medical gas vacuum system maintenance and record keeping, 5.1.14.4.
Thanks, Rich. Appreciate that. And John and Jeff, your insights there. Any other insights? So let's move on to our next question. This is in regards to ligature guidance. Is there any news from CMS on better guidance around creating a ligature-resistant environment in behavioral health? Herman, you want to speak to this one?
Sure. So let me start off by saying, we use the term ligature resistant. I know sometimes folks want to say ligature free. Well, we understand that's almost an impossibility. So we use the term ligature resistant. So I want to start off by just bringing that clarifying information. No, we have not received any additional guidance from CMS, but it appears good, that CMS has accepted the guidelines that the Joint Commission has come up with. Now, I want to say that the Joint Commission has not just come up with these guidelines in and of ourselves. We have convened expert panels for a few times which comprised of organizations and experts in the behavioral world, behavioral health world, to come up with these guidelines. And we also have an internal working group that reviews these guidelines, and we vet them with our officers. So at this point, it appears that CMS has accepted the guidelines that Joint Commission has put out in terms of the requirements or the allowances, so to speak, for a dedicated behavioral environment. And also, these can be, you can find these in our Perspectives magazine.
Thanks, Herman. Any other insights?
I'll just reinforce, as a facility that has gone through what I'll call a contemporary review of our inpatient behavioral health around ligature, that the guidance that Herman is mentioning here is really outstanding. From a facility perspective, it allows you to really engage with the behavioral health care providers in their areas and really make some concrete assessments as you plan out what to do. There are costs associated with it, obviously, but when you're working in that multidisciplinary realm there, the guidance that's out there that is on Joint Commission's websites and what they're providing is really an outstanding basis to move forward with your teams. It also gets into discussions, just aside from the physical plant, on operational best practices, how to do the checks without it really interfering with the patient care in terms of keeping a visual on the patient, doing one-to-ones and so forth. So really makes you look at your physical plant for what it is, do the proper assessment, and take action from there.
Great, appreciate those. Let's move on to our next question, which is in regards to suite doors. Do doors to suites have to latch? This would be in non-sleeping suites, existing healthcare, fully sprinkler building. Can these doors be held open with magnetic holder that releases on fire alarm? Can the 5 foot-pound of force be applied? John, you want to take this one?
Yes. So I think we're talking about the door that's to the wall that defines the boundary of the suite. So that's where I'll answer the question. So in 2000, at least the version of the Life Safety Code implied that these were smoke partitions, that this boundary wall was a smoke partition, but it didn't come out and say it. In 2012, the current version that CMS is looking at, it states it outright. I would argue, based on my memory, that's how most of us in the enforcement world were looking at it in the 2000 version. So the answer is yes, the doors would have to latch because you would apply the same characteristics to that suite boundary door that you would to a corridor door. So yes, they have to latch. Yes, this would include existing health care. Yes, it would include sprinklered, and it would include those non-sleeping suites. I think it can be held open in 2012. I think it comes out right and says that it can be on a hold open, but a closure isn't required in the first place because this is a corridor door. But if that's a mechanism you want to use, it's implicit in the code that you can do it. But again, we're applying the same criteria as a patient room door. So it's that 5-pound force, the concept of rebound. So really that's the prohibition on roller latches would apply as well. So I think if you look at the corridor door section in 101, you'll get all of that. In the ICC version of codes, that concept came, I don't remember exactly when it was, but it was around that 2012 point. I think if you have an existing healthcare facility built back in the 70s or 80s, you could make an argument that the suite language back then wasn't implicit, but I think since it's implied, you would have a tough time trying to win that argument.
I think that to add to what John was saying, that when we talked about this concept when we were talking about corridors, if a suite, if you envision it as basically a large room and you're protecting around that room, that's generally been the concept since really you started using suites. When you're looking at emergency departments and PACUs that are connected to corridors, but they have a lot more operational things going on in the back, to view that as that protection to the exit access corridor in basically your large room is probably the simplest concept to move forward with. Adding magnetic opens, that's usually a operational thing if you don't want to get your doors chewed up and there's enough traffic and there's not a security issue, frankly, and you can hold them open. We're seeing that more and more in ICUs and EDs where you want that door closed from a security plan. That's fine too, but really, again, the door to the suite is your door to that main room from the corridor.
Right. Now, if we're talking about the doors inside of the suite, I think these rules don't apply because, like we said, that long, skinny room inside of the suite is not a corridor. So the corridor door requirements don't apply.
All right, thanks. Appreciate that clarification. We are at the top of the hour, actually 1 minute past, so that's all the questions we're going to be able to handle for today. We appreciate the ones that came in through the chat. Any of the questions that were submitted online that were not addressed, although we did get all, I think there was one that we didn't get to, they will be addressed via My Action, so watch for that. We have recorded this session, and it will be posted online at the on-demand learning site, and there again are the future dates for next year's Just Ask ASHE webinars. Want to thank our subject matter experts once again for their time and input into this, and want to wish everyone a great facilities and engineering week, and thank you for your time.
Thanks, everybody.
Thanks, everybody.
Thank you, ladies and gentlemen. This concludes today's presentation. You may now disconnect.